Good morning, pre-calculus. Today we get to look at section 10-8, the last section of chapter 8, which deals with conic sections. So what we're going to look at today is we're going to look at polar equations of conics. So what we're planning on doing is, if you look at the essential question, how do you represent a conic section? In other words, how do you represent an ellipse, a hyperbola, or a parabola as a polar equation? So again, it's not a difficult section. We're going to have to go back and remember some things from the rules from conic sections to be able to do some parts of this, but it's relatively easy, and we're going to mostly use our calculator. And I think it would be a good idea right now, and since we're dealing with polar equations, we need to make sure our calculator is set up for polar equations. So once again, to do that, you take your calculator, you go to mode, and right now my calculator is set up to represent graphing of functions. So what we want to do is we want to set it up to graph it as a polar function. So where it's highlighted as polar, we just hit enter. It is highlighted. We're ready to go. We can quit out of that. Our calculator is now designed and set up to graph polar equations. So again, you'll probably know it's a polar equation because if you hit y equals, you'll have it represented as r equals something. That is the equation form of polar. Okay. So how do you represent conic sections in the polar coordinates? Now I just have 3 examples. I'm not going into full detail on this section because I'm going to let you guys do a little bit of analyzing and rethinking everything about conics. So if you look at the whole section, we can represent conics as polar equations in one of 2 ways. And pretty much we'll be able to see how to do that in a moment. So again, these are our 2 polar equations that represent conics. A couple things we need to know here is where E is the eccentricity of the function, or in this case, the eccentricity of the conic. Now again, you have to go back and do some thinking. Remember, eccentricity has to deal with, the wideness of the conic, and in this wideness or narrowness, and that goes back to the equation of C divided by A. And that C divided by A, again, that deals with the Pythagorean theorem and the analysis of conics. And I'm going to let you guys to be responsible to go back to the 4 different types of conics and figure out what the E is, okay? You have all that information. I'm not going to go over that. Now, P in the polar equation is the distance between the focus and the directrix. Now, again, you should know what a focus is, and you should know what a directrix is, because that all deals with conics. Now, for the conic, in this case, it's going to be one of 3 things. It's going to be an ellipse, a parabola, or a hyperbola, and it's all, in this case, for polar equations, it's all dependent upon what the eccentricity is. So if your eccentricity is less than 1, it's going to be an ellipse. If your eccentricity is a value of 1, it's going to be a parabola. And if your eccentricity is greater than 1, that's going to give you a hyperbola. So let's see how this is done. This is the gist of section 10-9. So let's do some examples, just see how it works, okay? Here's our examples. Let's identify the type of conic represented by the equation. Not only are we going to identify it, I like to also graph it, okay? So here is our first example. We have r equals 2 divided by 2 plus cosine of theta. So if you go back up to this example, pictures out of it, up to this part right here, you're going to probably notice in your denominator we have to have a value of 1 right here. So again, if you take your problem, what we got to do is we got to get a 1 right here, so I have to divide him by 2. And then since we're dealing with an equation, we have to divide everything by 2. So that's what I did right here. And then simplify it. So this part right here is your polar equation that represents a conic. And we see here that the e in front of the cosine of theta, that is 1/2. So we know from the rules, since e is less than 1, we know that this is going to be an ellipse. So let's see what this looks like graphically. Now what I'm going to do is I'm leaving it like this. This is what you got to do to get it as equation. But what I'm going to do is I'm going to graph it up here. It does not matter which one of these two you graph. You're still going to get the same graph. So I'm going to graph this one. Or better, yeah, I'll do this one. And you guys can do both to see what the difference between the two is. Okay, ready? So here we know that it's 2 being divided by parentheses 2 plus the cosine of theta, parentheses, parentheses, and we hit graph. And there again, if you look at it, there is the graph of this polar equation. It is an ellipse. That is what this section's all about. It's really not that difficult. The hardest part will be later on figuring out what E is, and P is not going to be that difficult. Figuring out what E is you're going to have to do a little bit of studying on that. All right, let's do equation example number 2. Here we have R equals 12 divided by 3 minus 4 sine theta. Again, this term right here, 3's got to be 1, so we have to divide everything by 3. There's your polar equation. Then if we look at it, okay, we know that if we go back, this is going to be 1 minus e sine theta, so it's this one right here. Now again, the thing to remember in this case, e is going to be 4/3. Okay, we don't have to worry about that minus sign. It's going to be 4/3. So e is 4/3. And then since 4/3 is greater than 1, this is going to be a hyperbola. And we can graph it. Okay, I'll do that one more time. It's a hyperbola. I'm going to use this first equation. I didn't have to, but I just chose to. For sine theta, I'm not talking here. I need to let you guys know I'm alive. 3 minus 4 sine theta, hit graph. And again, that one looks, if you look at it, I'm going to zoom it out just a little bit. I'm just going to zoom it out a bit. Now again, those two diagonal lines, if you remember correctly, that's your asymptotes. Again, they show it here in this example. While I'm at it, let's go ahead and graph this one. So I'm going to clear this one, just let you know that they are the same problem. So 4 divided by parentheses 1 minus parentheses 4 divided by 3 parentheses the sine of theta, parentheses, parentheses, and graph it. And if you look at it again, it's the same problem, just graphed this way. Okay? That is what part of this section is all about. Now, the next part of this section is finding the polar equation when they give you some information. So again, find the polar equation of the parabola that has a focus at the pole. Now again, the pole for these problems is when you have a fixed value at the origin. In this case, the fixed value is going to be your focus. And it has a directrix at x equals -4. So what I did is, just before I get started, at the bottom of the page, okay, I just happen to take that particular information. We see that our focus is at one of the poles, which in this case, it's at the origin. The directrix we know is an imaginary line. It's there. That's x equals -4. Now again, if you go back to the section on parabolas, you'll be able to identify all this stuff. That's your focus. Oops, use my pencil. That's your focus. There's your vertex. There's your axis of symmetry. Okay, sorry, that's your directrix. That's your axis of symmetry. That right there, you can get all your information to put it in the equation form. But what I want to do is keep it in context with your book. So we see that the directrix is vertical, and it's left of the pole. That's your pole, which is your focus. And the polar equation will be this guy right here. Again, that information I told you about is on page 795. Okay, now if we take all this stuff, again, if we did our math, your eccentricity is going to be 1. Once again, that's C divided by A. I'm going to let you go back and do your research on a parabola. P, once again, is going back to the definition. It's going to be from the distance between the focus and the directrix. So the distance from the focus to the directrix is 4 units. So there is your polar equation. Well, let's see if it looks like that. Okay, I just wrote down this information just based upon the directions. Okay, let's see if it really looks like this. So you go y equals 4 divided by, parentheses, 1 minus the cosine of theta, double parentheses, and graph it. Let's probably put this into the regular zoom so you can see it a little bit better. Oops, paused it. There it is. It looks just like this one. So again, we did it correctly. So this whole section is taking conics and writing them as polar equations. So this is section 10-9. I don't think you'll have any problem with this section. All right, guys. Thank you very much. Have a good day.